Okay, here's our fourth in the series of live broadcasts on revising for your A-levels. We're going to be looking at integration by substitution, and also we're going to be looking at differentiation using the chain rule. And we'll start off with differentiation using the chain rule. Sorry about that. That was the live stream going in the background. You can see that it's lagging. So anyway, going back to the chain rule, we're going to look at some easy questions, and I'm going to show you how you can do the chain rule using your, just by looking at the questions and doing them in your head. To start off with, let's just look at it formally. So if we take a nice straightforward one, y equals, let's have a look, 2x plus 1 all to the power of 9. So we don't really want to try and multiply that out using the binomial, then differentiate it. It's much easier to use the chain rule. And the chain rule, we use dy by dx is equal to dy by du dot du by dx, or times du by dx. And what we do is we let u equal something. So we're going to let u equal what I call the inside function. Here's our inside function, 2x plus 1. And then we've got our outside function to the power of 9. So let's let let's u equal 2x plus 1. And therefore du by dx, we always differentiate the two things, equals 2. And then if we therefore y will equal u to the 9, because u is equal to 2x plus 1. And we can get dy by du. And that gives us 9u to the 8, differentiate respect to u. So therefore, dy by dx will equal dy by du dot du by dx, which is equal to 9u to the 8 times by 2. And if we simplify that, that's equal to 18. We know that u is equal to 2x plus 1. And we've got that to the 8. Now, that's how to do it using the formal methods. And it'd be much better that we actually did this in our heads, because it would save us time. Now, this is how I go about doing it in my head. So I've got y equals 2x plus 1 to the 9. And what you do is you differentiate what we call the inside function. So 2x plus 1 differentiate is 2. And then I times that by the derivative of the outside function, which is the something to the 9. The whole thing to the 9. And we just treat this bit as, say, like x to the 9. And so x to the 9 would differentiate to 9 times the something to the 8, the inside bit. So that inside bit is 2x plus 1. And we get dy by dx just equals that. Simplify that. That gives us 18 times 2x plus 1 to the 8. So that's how you can do it in your heads. Alright, what I'm going to do is give you another one to have a go at. Just give you 30 seconds to see if you can do it in your heads. And then what I'm going to suggest is using the chat is... Mr. Gobbler, thank you very much for your love of maths. Can we keep the chat to something sensible, please? While I'm doing that question, while you're doing this question, if you finish it quickly, maybe you'd like to suggest some tricky ones, and we maybe have a go at them, the best ones that you suggest to do in your head. So here's one to have a go at. How about you have a go at cos x cubed plus 1. Nice, straightforward one for you to do. Have a go at y equals cos x cubed plus 1. And then when you've done that, why don't you type up one of your own for other people to try? So I'll give you a minute. Sorry, I just realised the microphone was off. Sorry about that. I was suggesting that you guys come up with your own solutions to some of your own questions. See if you can come up with a trickier question than I've done. There's one I've got, tan cubed 3x squared plus 2. Let me know if you can come up with another one to do, if you finish that one before I finished it. Right, this one's quite a tricky one. Let's have a look at it. In fact, I think actually it would be useful if we did some of this letting u equal something. And if I was to just let u equal tan of 3x squared plus 2, just to give me some stages, and therefore y equals u cubed. Because actually we're going to be doing this bit here is a chain rule problem in itself, so we can do that in our head. To practice doing them in our head. You wouldn't normally get something quite this difficult, but you never know. So du by dx, if we differentiate the inside bit, we get a 6x squared. And then we differentiate the tan, we get sec squared of 3x squared plus 2. And dy by du will equal 3u squared. Now, therefore, dy by dx will equal dy by du times du by dx. That's 3u squared. Now, u is equal to all of this, tan 3x squared plus 2. And we want to square that. And then we're going to times that by 6x squared sec squared 3x squared plus 2. And we can simplify that a bit down if we wanted to get 18x squared tan squared 3x squared plus 2 times sec squared 3x squared plus 2. Right, let's have a look at an exam question now. And here we go. We've got a 10-mark exam question for you to have a go at and see how you get on with this. I'm going to give you about 6 minutes to have a go at it. If you can't get it done in that time, you feel like you're getting somewhere, feel free to pause the stream and finish it off. And if you're not getting somewhere, it might be a good idea you just listen. Right, I think that's enough time to have a go at that. Let's go through the question now. So we're going to start off with differentiating cos 2x root x. I mean, it's very rare you ever get a question that's just going to be chain rule, but we'll go through this and we'll start off with this one first. So we've got this as a quotient, so we're going to let that equal to u over v, sorry, u over v even, because the formula you've all been taught is that way around, and we know that du by dx will equal, what's it going to be, 2 sine 2x, and it's going to be minus that because cos goes to the minus sign, and we know that dv by dx will equal, derivative of x to the half is going to be a half x to the minus half. So therefore, dy by dx, or the derivative, actually we haven't got a y here, so we shouldn't really say dy by dx. Rub that out. So d dx of this will equal, if you know the formula, is v du by dx minus u dv by dx all over v squared. And you must know that off by heart. It's very important you know all your formulae off by heart. So we know that v is equal to root x times by du by dx, which is minus 2 sine 2x, minus, we've got u, which is equal to cos 2x times by dv by dx. So we've got cos 2x times by dv by dx is a half x to the minus half, all over x squared, v squared, which is just x. And we can simplify. You don't really need to simplify that down because it hasn't asked you to. Okay, so you haven't, because it hasn't asked you to, there's no actual real need to do that. That will do as an answer. It didn't ask us from the simplest terms, and it didn't ask us any specific format, so I wouldn't waste time in trying to simplify this. Now, in part B, we are going to differentiate sec squared 3x. And if you differentiate sec squared 3x, we got somebody just walking past outside. If you differentiate sec squared 3x, we're going to let the u, the bit inside, equal the sec 3x. And sec x goes to sec x tan x, so therefore that will be 3 sec 3x tan 3x. And then we've just got the outside bit, u squared, differentiated, so that's just going to be another sec 3x times by 2 differentiated. Sorry, I haven't really explained that very well. Let's just show that in all its form. You've got u equals sec 3x, du by dx equals 3 sec 3x tan x. And if we were to let y equal u squared, then we get dy by du equal to 2u. And the u was a sec 3, and that's where that 2 and that u came from. So therefore, if we times this all out, we'll get 6 sec 3x, and that's going to be squared because there's a sec x and a sec x there, or sec 3x, times by tan 3x. Now we want to get this all in terms of just tans. So give ourselves a bit of space. And we get equals 2. So this is just 1 plus tan squared. (3x) times by tan 3x. So we get 6 tan 3x plus tan cubed 3x to get that bit. Right, let's have a look at this one. Given that x equals 2 sine y over 3, let's find dy by dx in terms of x. Well, first of all, the easiest way I think to do this is just actually find dx by dy. So let's do dx by dy, and we'll get the sine goes to minus cos. So we're going to get, no, it doesn't go to minus cos, it just goes to 2 cos. And we've got a third coming out as well, because you've got the y over 3 differentiates to 1/3. So there's another little bit of chain rule. So you get 2/3 cos y over 3. And if we reciprocate that, we get dy by dx is equal to, check I've, yep, that's okay, happy with that. So I just want to make a mistake, check I hadn't made a mistake. So we're going to get 1 over 2/3 cos y over 3. Now we know that cos y over 3, if we square that, is equal to 1 minus sine squared y over 3. And this is a usual trick for this, to get these back in terms of x. And we know that x is equal to 2 sine y over 3. So therefore sine y over 3 will equal x over 2 if we divide both sides by 2. So therefore that's just equal to 1 minus x over 2 all squared. Because the sine y over 3 is equal to x over 2, and then you square that, you get x over 2 all squared. So this is equal to 1 over 2/3. Now if we square root this, then we just get cos y over 3. So therefore we get 1 minus x over 2 all squared. And it asks us to simplify our answer, so let's just see if we can do that a bit further. So if I multiply out, let's have a look. We get 1 over 2/3 square root of 1 minus x to the 4 squared equals. Now I'm going to take a factor of a quarter out of here. I'm going to take a factor of a quarter out of here. So if you take a factor of a quarter out of there, you're going to have to square root it, so that will give you half. So that will give you 1 over 1, actually just not do it all in one go, 2/3 times by a half. And if I take dividing this, if I'm taking out a factor of a quarter out of here, I've got to take a factor of a quarter out of here. So that'll leave me 4 there and minus x squared there. So this little half here is me taking a quarter out of there and there. So take a factor of a quarter out of there, divide 1 by a quarter, you get 4. Take a factor of a quarter out there, it leaves me just x squared. And if we simplify that, there's the 2's cancel, so that's 1/3. So this is just going to equal 3 over the square root of 4 minus x squared. And that's another question from the infamous 2013 paper. So for what was not a huge number of marks, it's quite a lengthy question. So you can see we've got some more further questions here for you to practice. If you didn't get that done in the time, I would suggest you have a go at doing that. Now let's move on to some C4 and look at the integration by substitution. Now, integration by substitution, you can speed up some of the questions if you know your differentiation by chain rule, okay? Because a lot of substitution questions are reverse chain rule questions, and you can actually just jump straight to the finish. Let's give you an example. I'm going to just think of one where I've got a reverse chain rule problem, but it could also be done by substitution. So if you let u equal x squared plus 1, we can see du by dx equals 2x. Now in all substitutions, you're going to look for the complicated bit and try and substitute that and see if it makes your integration easier. It doesn't always work. I mean, sometimes it's actually the easier bit, but 9 times out of 10 it's the harder bit you're going to be looking at. So we're going to use that in our substitution. So we know that x is going to equal a half du by dx. So this x here, oops, undo. This x here is equal to a half du by dx. So I'm going to replace that with a half du by dx, but I'm going to put the half here, and I'm going to put the du by dx here, and I've got the dx here, and then I've got x squared plus 1, which is just u, to the power of 3. So I'm integrating half u to the 3 with respect to du. Now integrate that, I'm going to get u to the 4, I'm going to divide by 4, which gives me an 8th u to the 4 plus c. So that's equal to 1/8 of x squared plus 1 to the 4 plus c. Now, we could have just done that in our heads using reverse chain rule methods. So if we just think about the integral of x, and I'll show you how you could have done this in your head if you can't spot it already. When you're doing these in your head, start off by looking at the thing that seems to be where all which seems most closely linked to what you think the derivative might be. In this case, we can see if you differentiate x squared, you get roughly x coming out, and you've got this big power. So why not think of it as just being x squared plus 1 to the 4, and then differentiate that and see what you get, because you should be able to do reverse chain rule very quickly in your head. Sorry, chain wasn't quite quickly in your head now. So you differentiate, you get 2x out and a 4 out, so you're going to get 8x x squared plus 1 to the 3 when you differentiate this. And we notice the only thing that's different between this and this is the 8. So we need to divide by 8. So we get 1/8. And you see, you can get to the answer quite quickly that way. Anyway, here's a past exam question. You can have a go two ways. You can either try doing it using substitution, but I actually think you can actually do it in your heads and do it by inspection, just the way that I showed you just now. As a 6 marker, I'll give you 3 minutes to have a go at this. Right, let's have a look at this. It does say or otherwise, so we don't have to use the substitution to do this question. So if I'm going to write this out, I'm just going to show you how I do it without actually using the substitution first, and then I'll show you how to do it using the substitution, just in case you're rusty on integration by substitution. What I can see is, I can see that this differentiates to give me this, roughly. So cos goes to minus sine. So therefore, my integral will be e to the cos x plus 1, and I'm going to have a minus e to the cos x plus 1. And I can check that by differentiating. Always check them by differentiating, just to make sure you haven't made a mistake. So if I differentiate the cos x plus 1, I'll get minus sine x. If I times that by minus e to the cos x plus 1, those will cancel to give me a plus. So therefore, I've got it right. So that is what this integrates to. So get between pi by 2 and 0. And what we're going to do is put that in. So if we put pi by 2, cos of pi by 2 is 0, plus 1 is 1, e to the 1 is e to the 1. Let's leave that. And then we'll subtract from that the 0 value. Cos of 0 is 1, plus 1 is 2, it's minus e to the 2. So that's equal to, therefore that's going to be minus minus a plus, so you're going to get e squared minus e to the 1. Take out a factor of e and you get what we need to show. I'll just do the substitution bit just in case you want to see how to do that. So let u equal, so we're going to let u equal cos x plus 1. So du by dx equals minus sine x. So therefore, minus du by dx is equal to sine x. So if we now substitute that in, we're going to get du minus e to the u du by dx because I've replaced the sine x with du by dx, or minus du by dx, I should say. Okay, if you want to speed things up, what you should do is you should also change the limits. So if x equals pi by 2, u will equal cos of pi by 2 is 0 plus 1, u equals 1. And if x equals 0, okay, if x equals 0, we're going to get cos of 0 is 1 plus 1, u will equal 2. So we'll integrate from 2 to 1. Okay, and you can finish that off and just verify that that integral from 2 to 1 of minus e to the u du actually gets you the same answer. Actually, let's just finish it off just for completeness, I suppose. So we put that in. Minus e to the u comes from minus e to the u. Put 1 and 2 in. So we're going to minus e to the 1 minus e to the 2, and that gives us minus e plus e squared, and we can see that's coming out to be exactly the same thing. So I'm going to rub that out. Exactly the same thing as we had before. Okay, another substitution. This one's a little bit more interesting. It's a 7 marker. I'll give you 4 minutes to have a go at this. If you think you're getting somewhere and you want to finish it off, just pause the stream. You can catch up later and finish it off. Obviously, if you're not getting anywhere after 4 minutes, you'll probably be wanting to hear the answer anyway. Give you 4 minutes to have a go at this one. Okay, that's enough time to do that question. Let's have a look at it. So I'm just going to zoom that out a bit so to give me more space to write my solution. So we are going to let x, pick a pen, we're going to let x equal 2 sine theta. So dx by d theta is equal to 2 cos theta. And if we know that x equals root 3, that implies that theta will equal, we've got root 3 here, divide by the 2, that's root 3 over 2. Inverse sine of root 3 over 2 is pi by 3. And if x equals 0, theta will equal 0, because 0 divided by 2 is 0, inverse sine of 0 is 0. So we're going to integrate between pi by 3 and 0, and we're going to substitute in 4 minus 2 cos theta. No, it's not 2 cos theta, sorry, it's 2 sine theta we're substituting in for x. 2 sine theta all squared, all to the power of 3 over 2. And here we can see from this bit here, that dx is going to be equal to 2 cos theta d theta. I never write that out because it's not really very good maths, but it's the simplest way of doing it. Okay. So we get 2 cos theta over, now let's square this out, so we're going to get 4 sine squared theta. 4 minus 4 sine squared theta is the same as 4 times 1 minus sine squared theta, which is just 4 times cos squared theta. So we're going to get 4 cos squared theta here, and we've got that to the power of 3 over 2 d theta. Now let's do this to the power of 3 over 2. So 4 to the 3 over 2 means you're going to square root the 4 to get 2, then cube it to get 8. And then cos squared to the power of 3 over 2, the squared and the 2 will cancel to leave us just cos cubed. And that's just equal to power of 3 naught. 2 over 8 is 1/4. Cos divided by cos cubed means we get cos squared in the bottom, so that's just sec squared theta. So that integrates to give me 1/4 tan theta between pi by 3 and 0. And tan of pi by 3 is root 3, and tan of 0 is 0. So this is just going to give me root 3 over 4. Okay, one last question. Bit of a biggie. Let's just zoom it in so you can see a bit more of it. There we go. A longer question, although only worth 8 marks. So you really have to be on your game to get this finished in time. So have a go at this. I'm going to give you 5 minutes to have a go at this, and then I'll run through this final question. Just in case you're struggling to see it, that limit there, right, that limit here is 3, and that limit there is 0. Okay, and that goes to pi by 2 and minus pi by 6 here. Okay, let's start going through this now. So we have the substitution is equal to x equals 1 plus 2 sine theta. So dx by d theta will equal, what's it going to be, 2 cos theta. And if x equals 3, then we can see 1 will equal sine theta. Take 1 off 3, you get 2. Divide by 2 gives you 1. Sine theta equals 1. So therefore theta will equal pi by 2. And if x equals 0, then we get minus a half will equal sine theta. Because we take away 1, divide by 2, and therefore we get minus pi by 6 equals theta. So let's put that all into our integral. So we have got the integral from 3 to 0 of root 3 minus x plus 1 dx will equal the integral. Now we're going to go from minus pi by 6 to pi by 2 of the square root. Let's see if we can fit this in. I might be struggling here. Move this up over a bit. Okay, so I'm going to get 3 minus 1 minus 2 sine theta in there, taking all that away from 3. And then I got that 1 plus 2 sine theta plus 1. And then I need to times by 2 cos theta d theta from here. 2 cos theta d theta. I need to times by that because that's what dx is. So 2 cos theta d theta. And let's just simplify all that. I won't write out the limits every single time. So I'm going to get minus, so 3 minus 1 is 2. So I've got 2 minus 2 sine theta. And then I'm going to get 1 plus 1 is 2 plus 2 sine theta. And we can see some squares are going to appear from this using difference of 2 squares. So this is just going to be integral of 4 minus 4 sine squared theta, 2 cos theta d theta. And it's important you show every step. So that's equal to, what's that the integral? That's going to be root 4 cos squared theta 2 cos theta d theta. Let's put our limits back in and now minus pi by 6, keep them going. Square root of that is 2 cos theta. Which gives us the result that we're looking for. 2 times 2 is 4 cos squared theta d theta. Okay, and now we want, so k is equal to 4 in this case. So k will equal 4. Now, we want to find the integration, the exact area of R. So we need to carry on with this. Now, cos squared theta is not, a lot of people make the mistake of jumping to cos cubed theta. Well, it's not a reverse chain rule, because remember, reverse chain rule, you'll get the cos will differentiate out to give you sine theta cos squared theta times by 3. And we don't have that sine theta, so we can't do this with a reverse chain rule. Okay, so we can't do that with reverse chain rule. So we need to use a double angle formula. Now, cos squared theta, now, if you can't remember it, you probably can remember cos 2 theta equals cos squared theta minus sine squared theta using the addition formula, or you can get the addition formula off the formula sheet and work that out anyway. Anyway, so if you get that, you'll know that 2 cos squared theta minus 1 equals cos 2 theta. So cos squared theta will equal 1 a half of 1 plus cos 2 theta. And so we put that in, so we get a half of 1 plus cos 2 theta d theta. Oh, and we've got our 4, don't forget our 4. So put the 4 over the top of that, so that gives us 2 of all of that. So that's going to integrate to give me 2 times 1 is 2. That'll integrate to give me 2 theta, and I've got 2 cos theta, so that will integrate to give me just sine of 2 theta. Pi by 2 and minus pi by 6. Put in pi by 2. 2 times pi by 2 is pi. Plus 0. Pi by 2 times 2 is pi. Sine of pi is 0. And you should know these off by heart, just like that. Minus pi by 6, so I'm going to get that times by 2, so that's going to be minus pi by 3. And then we're going to put minus pi by 6 into here, so that's minus pi by 3, a sine of it. Now, if you can remember your sine curve, well drawn, let's try that again. Okay, so there's where minus pi by 3 is. I remember my exact values go a half, root 2 over 2, root 3 over 2. You can learn them however you want, but you need to know that's root 3 over 2, so it's going to be minus root 3 over 2 here. So let's work that out. So we've got pi minus pi by 3, that's 4 pi over 3. We've got minus root 3 over 2, so that's plus root 3 over 2. Oops, sorry about that. As our final answer. Okay, what you'll notice in the further question. Now, question 2, interestingly enough, this was the International A-Level question. If you're wondering which out of the 3 was the International A-Level question, that was one of their easy ones. Again, for further practice, these are from the recent papers and these are from the International A-Level papers. Do go away and practice. If you could not do any of those, if any of those questions were not able to do in the time I gave you, because really you should be able to do them in that time if you're ready for your exam. And if you can't, then you need to get further practice. If there's anything specific, like an exam question that causes you specific problems, do feel free to email it and I might include it in a future video. I'll be carrying on next week. This is the last one I'm going to do this week, but I'll be doing some more next week, maybe 4 or 5 more of these sessions, building up through the course. And if there's actually anything specific you found difficult, send it through and I might hopefully will include it in a future video. Cheers.